My name is Trevor Branch, and I'm pleased to introduce the third Bevan talk. I'm on the faculty at the School of Aquatic and Fishery Sciences, and the Bevan Series this semester, this year, is on the topic of ocean acidification. That's the process where we put CO2 in the air and that ends up the oceans more acidic. Possible problems for things living in the ocean. Now the Bevan Series itself is here to honor the legacy of the late Donald Bevan, who was at one time the director of the school. He worked here for almost 50 years, and the fund that funds this seminar series was set up by his wife, Tanya Bevan. And together with funding from the Alaska Fisheries Science Center, the Northwest Fisheries Science Center. And I would just like to hand over right now to Liz Neely of Compass to introduce today's speaker, Miyoko Sakashita.
Hi everyone, I'm Liz Neely. I'm the Assistant Director of Science Outreach with a group called Compass. My job is to help connect scientists to journalists and to policymakers, and also help them prepare so that science is effectively brought into public discussions and also into policy decisions. So I teach science communication here at the university, and I've spent the past 2 years working on a book called Escape from the Ivory Tower. So it's this focus on taking science out of academic conferences and out of the journals and out into the public realm that gives me such pleasure in introducing Miyoko today. As our own Ray Hilborn says, we're in applied fields because we want to change how things happen. We want to have an impact. Other scientists are not our major audiences for some of this work. It's policymakers and legislators. If you want to change how the world works, you've got to engage with it. And Miyoko, who's a senior attorney and oceans director at the Center for Biological Diversity, certainly has a history of actively working to change the world. You should ask her about this at happy hour afterwards. She comes from a background as a dedicated activist in issues around currency and agriculture, and then she went on to earn her law degree from the UC Berkeley. Now she's focusing her skill and passion on the legal and political channels that we as a nation and a species might actually use to reduce our carbon dioxide emissions. Her overarching message, as you'll hear, is that we have the right tools, we just need to learn how to use them, or we just need to start using them. Now, for every problem, there are carrot and stick approaches, and it seems to me, if I've got this right, that Miyoko is carrying a pretty effective and rather large stick in this instance. She uses litigation as a tool to force these things through, and she's going to be talking about the legal framework that we have as a nation and how she is trying to translate the science that we have into that and apply those laws. I often hear from scientists that they maybe don't want to get involved in policy because it's all about politics, not about the science. They don't want to bother and waste their time. Miyoko, who is facing these battles every day, told me this morning that she relies on researchers getting their data into the policy pipeline and bringing issues to her attention for most of the work. So please help me welcome Miyoko.
I could use an even bigger stick if anyone knows where I can get hanged on that. So, can anyone here tell me why these snorkelers have this number of 350 on their kickboard?
Parts per million CO2.
That's correct. And what's the importance of this number 350?
We're already above it. We want to get down to it.
Exactly. So, as our informed audience member here said, this is the way we measure carbon dioxide in the atmosphere. A lot of your scientists know this already. But 350 is a very important target because, according to some scientists, this is a number that we want to stay below with our or get below with our carbon dioxide emissions in order to prevent what they've termed as runaway climate change. Now, right now, we're already at 390 parts per million in the atmosphere, and we've seen almost a degree Celsius of climate warming, and we've seen a 30% decrease in pH, or 30% change in acidity of our oceans. Now, this has already caused some impacts that we can see on biological diversity. We've already seen population declines of species. We've seen the rise of mass coral bleaching events. And we've also seen the decline of about 50% of the Arctic sea ice over the summer. Now, this is already the impacts we're having, and unless we can stay below this or get below this critical number of 350, scientists tell us we're probably going to reach a 2 degrees Celsius climate change scenario, at which point some of these tipping points start to kick in, and we may end up with what they've termed as runaway climate change, where we have scientists telling us that sea level rise will start displacing millions of people. We'll have about a third of the species on the Earth threatened with extinction, and many other repercussions on our biological diversity. So that's an important point that I want everybody to go away with, is that we have an important target that we need to get to, and we need to take action fast. I think Trevor kind of took away a little bit of my talk here, which is what is ocean acidification. Most of you already know what it is, but I know there's a couple folks in the audience that maybe are not as familiar with it, so I'm going to do the quick and dirty, I'm not really a scientist, but I'm going to pretend I am for a few seconds here with a handy graph animation. And ocean acidification is we're dumping about 22 million tons of carbon dioxide into the ocean every day. And I read that in order to visualize what a ton of carbon dioxide is in volume, it's about 483 Empire State Buildings. So if you would imagine that in an hour you dump 483 Empire State Buildings worth of carbon dioxide into the ocean, it's a massive amount of carbon dioxide. And what happens is it's going in and it's binding up the calcium carbonate ions and making them unavailable in the water, meanwhile changing seawater chemistry and pH. So, and this is how a non-chemist uses a chemist's description to show how this actually happens. Now, probably most of you have seen the Mauna Loa atmospheric carbon dioxide graph here, and it shows our carbon dioxide decreasing. And in tandem with that, we have pH declining in the ocean. Becoming more acidic. Already, I said, and you probably heard it predicted, it's already become 30% more acidic due to human carbon dioxide emissions. And by the end of the century, it's predicted to be 150% more acidic on current trends, current paths of carbon dioxide emissions. So, looking at this, I'm curious what folks have heard maybe from the previous lecture, which was the most stark effect or most interesting thing the ocean acidification is causing or strikes you. Does anyone have an example, maybe a biological impact that they've heard about?
Dissolving.
I heard a murmur. Over here.
Pteropods have trouble.
Yeah, so pteropods are a plankton in the sea, a very small butterfly of the sea, and they're having trouble building their thin shells that they depend on to survive. And this is important because they're kind of the bottom of the food web, so everything up the food chain depends on them. Is there another example of something that's happened that someone wants to point out, or could happen in ocean acidification?
Corals can't build reefs.
Yes, corals can't build reefs. So it's having, there have been studies and it's having impacts that are drawing from attention and being studied more. One of the things that I find most concerning about carbon dioxide pollution that we're faced with in current carbon dioxide emission trends is the species extinctions that we're likely to face on this planet. And I'm kind of talking about all impacts here, not just ocean acidification, but also weather warming, extreme weather events, things like this. Scientists are telling us that by mid-century, a third of species will be committed to extinction. And that actually by the end of the century, we could have as much as 2/3 of species on the planet threatened with extinction. Now, this is if we continue on the same carbon dioxide emissions paths. But if we can change course and really target that number 350 and get our carbon dioxide emissions below that number, we may be able to save most of these species. And that brings us to what I've been asked to talk about here are some of the the legal and policy angles that we might be able to use to address ocean acidification. And I'm a lawyer, so I'm going to talk about laws. And what I've found is that we have a lot of laws that are already in existence that have sufficient breadth to address the problem of ocean acidification. So almost any key environmental law that you can think about probably has some angle, some way to look at ocean acidification and either evaluate it or get some sort of handle on it through a legal bill. So I'm curious, could somebody mention a federal environmental law that they may have heard of that might help here? Yes, that's a very important one. And the Clean Air Act is, it actually started with a lawsuit that got carbon dioxide emissions as starting to be regulated under the Clean Air Act. And I think it's a very important law, especially for all the scientists in the room, because one of the things that the Clean Air Act gives us the benefit of over the climate bill that never actually made it through or would have probably been a lot of horse trading anyway, is that the Clean Air Act is really science-based. So the carbon dioxide limits the greenhouse gas limits that they're establishing for carbon dioxide and other greenhouse gases have to be based in science. And that's a very important tool that we can have, really taking the science that you guys are working on and applying it to management and pollution controls and really getting a handle on this. So I'm going to just go through a few of the other federal laws that might be brought to bear on ocean acidification, but I'm going to focus in on just a couple specifically so that I don't bore you all to death, and also because I don't know about all of this, so I'm just kind of pretending. So there's a Federal Ocean Acidification Research and Monitoring Act. That was passed rather recently. It's pretty obvious what it does. It provides funding for more research and monitoring. And so, yay, that's probably why we have some scientists in this room that are able to do what they're doing. Any sort of climate bill would obviously help us get a handle on greenhouse gas solutions. And the Clean Air Act was already mentioned. The National Environmental Policy Act, or NEPA. Now, this is kind of one of the grandfathers of environmental laws in the United States, and some of you may have heard of it. It's the law that requires that any kind of federal project or federal action, you have to do an environmental review before the federal government can approve it or fund it or grant a permit. So this could be a very important tool for ocean acidification because you could, for example, be permitting a coal-fired power plant, and you could say, all right, well, you need to look at the impacts of the carbon dioxide emissions of your power plant and what those environmental impacts are before you go ahead and permit this. So this is the look before you leap law that we have. And there's been very little so far analysis of ocean acidification impacts under this law, but I see it as a potential to have a lot more analysis of what are kind of everyday activities that are getting past the government and big developments that are being created, need to start looking at the impacts on ocean acidification. Now, what I'm primarily going to talk about is the Clean Water Act as a tool to address ocean acidification, and also the Endangered Species Act. So the Clean Water Act, it's our nation's strongest law protecting water quality, so it seemed like a really good fit. And here we have a water quality problem. We have the ocean waters becoming more acidic, and it's harming different species and biodiversity. So it was a really good fit for addressing ocean acidification. And now, while most people think that the Clean Water Act is requiring some kind of permit so that you can have an outfall that's chugging stuff out into a water body, the Clean Water Act has another provision of law as well. So there's one side that's, you can't put a pollutant in a water body unless you have a permit. There's another side of this law that says, well, for all those activities out there that are causing water quality problems and causing pollution problems, but we don't know exactly where they're coming from, or maybe there's a lot of different sources, so it's harder to just plunk a permit onto it. There's this other provision of the Clean Water Act called the 303D section, and I'm going to go into a little bit of detail about how that provision of the law works. So it has 3 basic steps. And here's where the reason I didn't become a law teacher. The first step is that all states have to create water quality standards. And so what this means is that this is a standard so that if you're meeting the standard, you have clean water, and if you're not meeting the standard, you have dirty water. And then if once all the states then have to go out and look at their different water bodies, and this includes coastal, ocean water bodies, and determine whether or not they're meeting these water quality standards. And all states have marine pH standards. Oops, going backwards. So then if your waters are dirty waters, they're not meeting the water quality standards, then you have to designate them. The state has to designate them as an impaired water body. So they go on a list called the 303D list. And once you have the, I guess, honor, it's not really on honor, of being on the 303D list, it's more the opposite, then that's when it triggers the next step, which is controlling the pollution that's causing the water quality problem. So here in this case, if you have water bodies that are not meeting pH standards for marine waters, they're impaired, and then you have to figure out some way to stop the pollution that's causing this problem. So in this case, we're potentially talking about figuring out ways to reduce carbon dioxide pollution that's causing the water to become more acidic. I'm going to bring this all to a more tangible level by using a case study, and I get to use Washington State as a case study. Now, I've done this presentation in a lot of different states. I'm actually from California. I do the presentation there a lot, and I always use Washington. So this is my first time that I actually get to talk about Washington in Washington. So, okay. Now, Washington's water quality standards are that human-caused variation must be less than 0.2 pH units. And 0.2, most of you probably know this, doesn't sound like a whole lot, but that's actually a very significant change in pH, about a 60% change in pH. And then another one, they actually have a lot of water quality standards. These are the 2 that I thought were most relevant to ocean acidification. The other one is that it must support extraordinary rearing and spawning for salmon, other fish, oysters, mussels, shellfish, and wildlife habitat. So here's 2 water quality standards that seem applicable to problems of ocean acidification. And if you can think back, you've probably heard about some of this from Dr. Feely's lecture, but I've also heard that you have to hear something 7 times before you actually remember it. So whatever I'm repeating here that Dr. Feely already talked to you about, or your previous lectures, just think of it as an opportunity to really embed it in your mind. For the last 6 years, oysters in Willapa Bay have failed to reproduce. And it's not only in that particular bay, it's actually spread to a lot of the commercial oyster hatcheries. For the past 4 years, the oyster hatcheries have had a lot of mass reproductive failure. The larvae are dying in mass mortality. And the main thing that they've been able to correlate this with is ocean acidification. Now, I spoke to this woman, Sue Cudd, who runs a hatchery called the Whiskey Creek Shellfish Hatchery. And she actually called me up because she saw a news story about some of the work we were doing and said I needed to talk to her because she had been successfully raising oysters for about 30 years, and then all of a sudden one year the oysters failed to reproduce. And it happened again the next year, and that's when she called me. And what she said was that it was completely devastating to see this collapse in the oyster hatchery, and that when they used to go out and clean out barnacles off their intake valves of the water that they would collect for the oyster hatchery, there used to be a ton of barnacles on it, and they used to have to go scrape them off. And now when they would go out there, they would only see seagrasses. So she had also seen a little change in the composition of species that were in the area, that were, and the main thing they could relate it to was changes in pH. Now, this is Dr. Feely's study himself. They did a cruise off the coast, the west coast of the United States, and went all the way from Canada down to Mexico, and found that waters affected by ocean acidification were already upwelling onto the continental shelf. and reaching shallow depths of 40 meters or 120 meters. So this was, in essence, exposing a lot of marine life in the water column to corrosive waters. Now, one of the things that I like to remember most about Dr. Feely's study is that the waters that were upwelling here were last at the surface 50 years ago. So the ocean acidification that we were seeing now happened when carbon dioxide levels were much lower than they are now. So we already have another 50 years of ocean acidification that's already in the pipeline. And we're seeing oysters already having problems on the west coast. It's alarming. I'm supposed to be sending the solutions, right? But there are also problems. We just talked about pteropods quickly before. This is an image that helps bring it to light. This is what they should look like under normal conditions, and this is what they can look like under really high levels of ocean acidification. They also, as I mentioned, have effects up the food chain. So if you have Dr. Feely mentions this also, a 10% decrease in pteropods, you'll have about a 20% weight decrease in salmon water. Another study that was taken off the coast of Washington at the point of Juan de Fuca found that in these tidal pools that they were studying, the biodiversity was starting to shift. So in years of low pH, they found that calcifying organisms like shellfish and sea stars and things like that were being replaced by species that didn't need to calcify. And at that same time, they also took some measurements and found that pH had been declining more than 0.2 units over a period from 2000 to 2008, and then continued to decline after that. Now, some of that is probably in part to carbon dioxide levels, is kind of one of the overarching things there. And also, there was a recent study by Dr. Feely in Puget Sound, which I know some scientists here participated in as well, that took measurements, found extremely low pH in the Puget Sound, and of which 25 to about 50% of that was probably caused by carbon dioxide. And it's a phenomenon that is accelerating because we're having more and more carbon dioxide pumped into the atmosphere. So all of that science looked to me like it was violating those water quality standards. So here we had something that said you can't change more than 0.2 from natural occurring conditions, and you have to be supporting all of this wildlife, you have to be supporting oyster rearing and all this stuff. So I took all of this science, and this is where you guys come in again. I took all of your individual research papers and I compiled them into this big stack. And at the time, I actually could get every single ocean acidification paper that had been published, because this was back in 2006 or 2007. And I submitted them to Washington State Department of Ecology, and I said, you need to see this, because this is telling me that our waters are impaired, and you need to put them on that 303D list that says these waters are impaired. And actually, this was the first ocean acidification denier that I had ever met, was this guy at Department of Ecology who said, I've never heard of this, and it kind of sounds like climate change, and nobody's really sure if it's happening or not. So in the end, I'm sure some scientists actually took a look at the papers because they were required to under the Clean Water Act. They decided not to take my good advice and list ocean waters, so they didn't put that on the list. So my next job was to go to EPA, because the way the Clean Water Act works is a little bit funky, actually. It's a federal law, so the EPA has kind of oversight of the whole law, but they've delegated a lot of responsibilities to the states. So like the water quality standards, the states come up with them, and they come up with these impaired waters lists. But the EPA ultimately has responsibility. So my next appeal was to the EPA. And so then I go running off to EPA, and there's been a little more science published in the meantime, and I hand them my big stack of papers and say, hey, look, you need to list these waters as impaired because Washington State didn't do it, and so you need to do it. And they also kind of said, no, we're not ready to do that yet. So they didn't do anything. And now this is the part where I get to convince you that lawyers are not totally useless, and that some of us are actually trying to create change and do good things. And a lot of the work that I do is called impact litigation. So I'm not suing people to try to extract sums of money or solve a contract dispute. But what I really want to do is change the policy around ocean acidification. And I ultimately want to see this become a very important issue that policymakers are thinking about. And one of the tools that I have under my belt is to use the law. So the next step that I did was I filed a lawsuit. So this lawsuit was called Center for Biological Diversity versus Environmental Protection Agency. And it was under the Clean Water Act. It was the first ocean acidification lawsuit to ever be filed. And I said that they basically had erred because they didn't list ocean waters as impaired under the Clean Water Act, and they needed to go back and fix that. Now, my goals in filing the lawsuit were much broader, I would say, than just getting mad at EPA for not listening to me. One of the ultimate goal and the overall thing I'm trying to do is get regulations on carbon dioxide. Now, I realize that this is actually a very long road to trod, and it's still many years down the line before the Clean Water Act is going to have pollution controls on carbon dioxide. But in the meantime, it's a very viable legal theory, and it was also the same way that the Clean Water Act used to approach atmospheric mercury. So I'm following a path that's already had some success. So they've used it to address atmospheric mercury, PCBs, and other air pollution that ends up harming water bodies. So we're kind of just following that same path. And even if the carbon dioxide regulation never comes to be through the Clean Water Act, there's some other important goals of the litigation that we filed. And that is that we have this ability to recognize when our water bodies are impaired by ocean acidification. So this is giving us an opportunity, a legal tool to say, let's go out and assess different water bodies and figure out which ones are in trouble. It was also an opportunity to take all that science and make the water quality managers read it in Washington, and also make EPA have to look at every single bit of ocean acidification science that's out there. And this is a really important step forward because back when I started doing this in 2005, 2006, a lot of people had never heard of ocean acidification, and to really make the policymakers and make the water quality managers look at the information seemed like a vital step in even getting anything done about it. And then finally, it's to elevate the issue and make it so that I'm not, I'm able to do something more than just, I guess, file a lawsuit, but it's also to create it as an important policy issue. And so here's something where now if we have the ability to kind of also push policymakers and say, hey, look, the Clean Water Act is now needing to look at ocean acidification. You should be looking at it too. Now, I know you can't read this, but ultimately what happened with this lawsuit is we settled it. And we settled it to get the EPA to open a public comment period to have people comment in and say whether or not they thought we should address ocean acidification through this provision of the Clean Water Act. And this is up here not to read or anything, but this is actually just the official publication of EPA saying, like, okay, everybody, send in your information. Give us what you have on ocean acidification. This was an amazing organizing opportunity. So I took advantage of it. And kind of part of that elevating the issue is we got 50 members of Congress to send in a letter to the EPA. And they asked the EPA to regulate ocean acidification under the Clean Water Act. We also had many, many groups organizing around this and sending in comments. We had over 60 groups kind of working in coalition, sending in comments. We had over 20,000 members of the public send in comments on ocean acidification. Probably, at that time I didn't even know 20,000 members of the public knew about ocean acidification. So it was a really good opportunity to spread the word that this is a serious policy problem and we need to start looking at it. And here are some of the impacts, and here's a solution. As well as we got a lot of media coverage of the issues. So this was another opportunity to educate the broader public that, with some of the science, the ocean acidification is happening. So out of that settlement, all I got was initially the public comment period. But what ultimately ended up happening was EPA had to do a decision memo about if they were going to do anything about ocean acidification. And this is the big thing that's happened so far, is legal approaches to ocean acidification. EPA concluded, yes, states, you need to do this. States should list their waters not meeting water quality standards, including marine pH, on their 2012 impaired waters lists. And 2012, although it kind of sounds far away right now, it's the next list that's about to come out. So already a lot of the states are starting to work on their 2012 lists. And the EPA decision memo said a couple of other things. One is that states, you need to go out and solicit information about ocean acidification. You need to, you recommend that you also figure out ways to assess whether your water bodies are impacted by this. So you need to figure out what the baselines are. You need to know what the water bodies are like now, so you can have some gauge to measure that against. And then we also recommend that you start monitoring for ocean acidification. And at the same time, it also did recognize that a lot of the science is still missing, and we have data gaps we need to fill. But this decision memo out of EPA that came out last November was kind of a sea change in using the Clean Water Act for ocean acidification, because it took this kind of crazy legal theory and it said this states you have the authority and you have the duty to address ocean acidification using the Clean Water Act. So we can expect that in this next round of impaired waters lists that all the coastal states have to come out with, they're all going to have to start to look at ocean acidification, which is something that hasn't happened before. Now, it doesn't mean they're going to list them immediately, but I've still got that hammer, right, the stick. So the next steps, what do we do now that EPA said, okay, yes, this is a viable way to go about addressing ocean acidification. The next thing, I've actually petitioned every single coastal state to include on their impaired water bodies list ocean waters for ocean acidification. And as more and more science is coming out, it's quite a process, but you have to send it to all of these individual states. So that's where you guys can help me also, is send your ocean acidification science and impacts of what's going on to state water quality managers and EPA, because they're looking at this now. And EPA in their memo, they also said that they're going to come out with a guidance. So that means that they're going to try to define some of these parameters of how states should be looking at ocean acidification and deciding how it's a problem and what to do about it, how to eventually create controls on the pollution that's causing the problem. So that's going to be another step that I need to focus on, is making sure that EPA actually does come out with this guidance as promised. A third piece that still needs a lot of attention and is the next step is those state water quality standards that I pointed out. Washington's are actually pretty good, and they don't allow more than a 0.2 change in pH. But some states are much more lenient than that and allow any kind of pH between 6.0 and 9.0. So you're obviously not going to capture, you're going to have a lot of dead things before we get there. So I need to go through another process of updating the water quality standards, because these water quality standards were created back in the 1970s. So they weren't thinking then of ocean acidification as the pollution problem. But they have a duty to go back and revise these water quality standards as new information comes out. So that's going to be another target that we can start to look at, and we need to. And I could use scientific help in figuring out how we want to define what these water quality standards should be. Should they be how much calcium carbonate is available in the water? Should they be a pH standard? Are there other things? Are there biological stressors we should be measuring instead? There's probably a lot of different opportunities to weigh in on that. And then we also need to build the political will around this, because another hurdle that I faced in petitioning all of these coastal states to do the impaired waters listing is that this is not their high priority problem. A lot of them haven't heard of ocean acidification yet, or, oh, that's something that's happening, out in the main ocean, so it's not much we can do about it here in our state. And so it's kind of building, I need to build some of the momentum to also have a lot of public and political support for going ahead and doing this. Now I'm going to switch course and talk about the other law that I said I'd go into a little more depth about, which is the Endangered Species Act. And as we know, some species are more vulnerable to ocean acidification than others are. And this, for us, can be an opportunity to highlight some of those early indicators of things that we might see coming down the pipeline with even higher carbon dioxide emissions, and try to get some recognition of ocean acidification and also some action towards curbing it. So corals have been one of the most studied species that has obvious impacts from ocean acidification. One of our audience members pointed out. And this is a coral after 8 days of growth under different scenarios of ocean acidification. So this is what it's supposed to look like after 8 days under normal conditions. And then, depending on, here it says we're building any skeleton at all. And so one of the things that I've done is try to highlight that carbon dioxide pollution is really imperiling certain species. And corals maybe are, according to some of the key coral biologists, one of the first worldwide extinctions of the ecosystem that we might have is among coral reefs. They predict that by 2050 we might have most of our coral reefs disappearing. And we're already reaching stages where we're having almost yearly bleaching events. And this last year, 2010, it was the second on record most deadly year for ocean temperatures for corals, because we had major bleaching worldwide and a lot of mortality from that. So we did a petition to list 83 species of corals as threatened or endangered under the Endangered Species Act, and using as the primary threats to these corals both global warming from carbon dioxide, greenhouse gas pollution, and ocean acidification as the overarching threats. And so now what these corals will do is they're going through a listing process. They got past the initial hurdle, and they've gone all but one. And they've gone on to a full status review to determine whether or not they should be protected under the Endangered Species Act. And they're following a couple other important species that are also impacted by ocean acidification that have already been listed. So back in 2004, we petitioned to list staghorn and elkhorn corals, which occur in the Caribbean, and they had declined by 90% over 30 years. And most of that was in a couple of mass bleaching events in certain years. And we petitioned to list them, and that became kind of the first species that were put on the Endangered Species Act list because of threats of global warming. Now, you probably all heard of the polar bear, and it got a lot more notoriety when it got listed as threatened, but actually these corals beat them out as the first ones listed for that reason. And the Endangered Species Act, the reason why this is a tool that I'm pointing out is it's important for more than just protecting these species, but potentially reducing carbon dioxide emissions as a whole. So first of all, by listing a species, we're raising the educational element that, hey, these things are in trouble. We're going to lose our coral reefs. We have 83 species of corals listed. That's a problem, and that shows a real ecosystem falling apart. We also get habitat protections that come along with Endangered Species Act listings. So they designate critical habitat for species, and they also have to define what the important essential elements are for those corals to survive. And when you have critical habitat protection, you're also able to prevent other stressors or other threats. So corals are threatened by a bunch of things. They're threatened by fishing, they're threatened by pollution. And so you have an ability to also curb some of those other threats to the species. So hopefully they can be more resilient or last longer so that they can withstand stronger stresses from ocean acidification or warming. As well as you could also potentially protect water quality or pH changes with critical habitat. Recovery planning, so the agencies have to figure out how they're going to get these species back to a good level where they are no longer need to be listed. And the most important provision of the Endangered Species Act that has the most teeth is the consultation provision. And it says that any federal agency action has to ensure against jeopardy of threatened or endangered species. So a part of that means that if you're permitting any kind of big major project, you have to look at the impacts that this is going to have on threatened and endangered species. And here, that could even extend to carbon dioxide emissions. So if we have a massive amount of coal-fired power plants, for example, being permitted, and they're causing emissions that are going to kill off the corals in the Caribbean, then that's potentially something that they need to consult on. And they actually have to take action to prevent the jeopardy. So they'll have to change whatever it is that they're approving, where they can do it. So there is a potential there to eventually have some sort of look, at least, and hopefully some action on reducing carbon dioxide emissions that could be causing species to go extinct. Now, just to kind of wrap everything up and tell you, what I'd like to do is say that in sum, we have the legal tools available to us to already impact some of the carbon dioxide emissions that are causing ocean acidification. And in par with that, the scientists in the room have a very important role to play. And we can take the science, which is vitally important to understanding this critical problem, and change it into policy solutions. So here's an example of where I took all those papers that had been published on ocean acidification and put them in front of the water quality managers, put them in front of the federal decision makers. And I'm trying to use that very important science to influence where we're going with approaching ocean acidification under the Clean Water Act. So it's important for taking action to have a lot of good science backing it. And then we can change that action into educating the broader public, educating policymakers so that we do impact a much larger global awareness of the problem of ocean acidification and hopefully policy solutions to it. And then hopefully we'll reach that target of 350 parts per million. And we need to start taking action now, and we know enough science to know that we need to do something now to reduce carbon dioxide emissions. Thank you.
There's time for several questions, and then afterwards there'll be a lunch section.
Okay. I also have not enough handouts, but some handouts that have who to contact at the EPA and at the Washington Department of Ecology to tell them that you want them to do something about ocean acidification. So. Hi.
I'm a little confused about what sort of actions do you think the government might be able to take in order to regulate global CO2 level, or even emissions from the United States? I mean, we're going to keep, basically have to stop burning fossil fuels and get our energy some other way. And this won't happen as long as fossil fuels are the cheapest form of energy.
How do we get there? So once I get the impaired water listing, then how do I get to that step 3 where we get the actual carbon dioxide controls? And the Clean Water Act is actually quite flexible in the way that it imposes those controls. So what I'm going to get a little wonky here, but then I'll try to simplify it, which is that you have to create these total maximum daily loads, or TMDLs. They have to figure out how much pollution is coming and from what sources are causing it. And then they have to allocate that total calculation among the different sources and what they need to do to reduce it. Now under the Clean Water Act, they have probably too much flexibility in how they actually implement it. So they can use any sort of methods that they want to. So they could do a cap and trade program, they could do a voluntary program, they could do command and control pollution controls where they say, X power plant, you're only allowed to emit this much carbon dioxide. So there's a lot of flexibility in how the TMDL is actually implemented to supposedly get the water body back into compliance. And then in terms of, I think what I saw is the bigger part of your question is like, well, this is a global problem. How are you having kind of state-by-state solutions to it? And that is a really good question. And that's the next step I need to take to figure out how we do that. But there's a similar problem with mercury. Now, it's a little more, atmospheric mercury is also a cross-border problem. And they're using this approach there, and one of the things that they've done is use regional TMDLs. So they get a bunch of states together, and they say, okay, here's all the sources of mercury pollution, and we're all going to agree together that this is what the targets should be and how we're going to do it. So I think actually it would be great if I had my dream of how this would work, EPA could create a nationwide program of allocating carbon dioxide emissions to the various different sources and how much they're allowed to pump out to keep waters in compliance with the water quality standards. Now, abroad, it is more of a challenge, but the U.S. has enough emissions on our own that whatever we can do is an important step. And even, for example, California is the second largest emitter in the country, and whatever California could do to reduce its emissions would already make a big improvement. So we need to act on all levels. I'd like to see global controls, but if we can do something on a state-by-state or even local level, it's still important.
Can you expand on that a little more and explain? So if there's one state that says it's fine if pH goes down to pH 6, and Washington State says it's only the top 0.2 units, and then let's say in your dream scenario, EPA comes up with some scenario to try to get the entire country to allow possibly for pH not to drop 0.2 units. Won't that other state just sue the EPA and say, our water quality standards don't say we have to drop down that much, so why should we have to make any changes to our industry?
I'm not saying that they won't sue the EPA for doing that, but the Clean Water Act is pretty clear, actually, that the EPA gets to recommend water quality criteria, and states have to adopt those water quality standards unless they have a really good scientifically based reason not to. So I think EPA would have a pretty powerful stick itself in saying that, well, ocean acidification is causing us to meet this water quality standard to protect waters. So, but that's not to say there wouldn't be a challenge, but I think that they have a pretty good argument why they could enforce something like that.
I wonder how the public and consumers will react to products caught or reared in impaired water. So right now, the oyster growers if they rear a product in the water with people's cold farm, it's obvious we ought not to consume it. But an oyster reared in slightly more acidic water is edible. If increasing coastal states are designated impaired, will that affect products in any way?
That's an interesting question, and it's probably something that I should talk to the oyster growers about. The most of the reaction that I've gotten from both kind of the fisheries community and the oyster community, shellfish harvesting, is that this is such an important problem that we need to do something to prevent the loss of our fisheries and the loss of shellfish. And so the legal tools that we have to get a handle on it are more important. But that's not to say everybody would feel that way. I'm not sure how the public would react to it. Most people don't know whether the waters are listed as impaired or not, but the general public. In the green sweatshirt, yeah.
I don't know if you've read the book Breakthrough or the Death of Environmentalism. There's an institute, I guess, based in San Francisco. They make the argument based on their experience with litigation in the U.S. around environmental laws. Their argument is that litigation is not going to get us out of this greenhouse gas problem. The reason for that is that environmental litigation becomes so incremental that we just aren't going to get the big changes we need to reverse extreme climate. That's one reason. The other reason is that it's global issues identified. And their main pitch is that we got to think twice about how we approach this. Litigation is not going to provide mechanisms to actually change emission rates. And instead, we really need to focus on carrots rather than sticks.
I would happily do carrots as well. Yeah, I hear what you're saying, and I have found that a lot of the impact litigation that I've been involved in, you do make some incremental changes, but hopefully, one of the other things we're trying to do is say, this is important enough to cause these waters to be listed as impaired, so we need broader political action on this topic.
Mercury example, sure there's been success in terms of getting mercury litigation on the table. Correctly, mercury concentrations continue to increase.
We absolutely need more than just a few lawsuits as well. We do need global action on carbon dioxide. So I'll agree with that. I'll still continue down this path with my stick, but I think we need a totally integrated path of all sorts of action on many different levels, even as much as not driving our personal cars and riding your bikes or taking the bus, and things we can change in our individual habits, up to big policy changes and hopefully global treaties and agreements to address this problem. I think we do need all of those things working in concert.
Yeah, you pointed out that you weren't going to talk about it, but with regards to NEPA, I was curious about the strategizing you might have done to decide between these kind of different possible legal, instruments. What thinking you do to decide which avenue to take.
Yeah, the Clean Water Act seemed like a really good fit because a lot of ways ocean acidification can be seen as water pollution. And so that's the reason that we selected that. NEPA, you have to do a lot of analysis, but it doesn't have as much teeth in actually making you do some sorts of controls or reduce your pollution. So I was trying to pick laws that would actually have a potential regulation component. Now, admittedly, that's still a long ways down the road. Okay.
Well, one of the global places where the United States participates was in the IMO, the International Maritime Organization, and ships are burning the dirtiest fuels on the planet. Residual fuel is referred to, the stuff they don't bother to refine anymore. And one of the ways in these emission control areas that are coming in that's being discussed is we can meet these standards by putting the emissions through a seawater scrubber and then dumping the acidified water into the ocean as a way to clean up the air. And I was just wondering if you've looked at this clever solution as and the United States being a participant in the EPA, there might be some legal angle in which we could, bring a global solution to at least to this part of the emission community.
I haven't looked at that particular techno-fix. I'm waiting for a real techno-fix that I'm kind of doubtful that there's one out there. That one in particular sounded problematic when it comes to ocean acidification, right? I think that's the IMO would be an interesting body to look at. Or
the alternative is you just burn lower sulfur fuel in the first place.
Yeah,
right.
Make ships go slower and they burn less fuel.
Right. But I mean, just like if you make them burn cleaner fuel, so you don't need to scrub it. And the problem is that they don't want to spend the money.
All right, I'll write that down.
Okay.
Chapter 2.
I'm kind of fascinated at the way that agencies, when they're faced with a new problem, will often bury their heads in the sand and say, we don't understand this, so we don't have to regulate it. So I'm really curious as to what ecology and EPA's arguments were for not for avoiding this 303B question. Obviously, they failed. Their arguments failed. But
The most common, and actually it was a settlement, so we never got to decide if the arguments failed or not. That's chapter 2 also. And then we'll move on to the IMO thing. But the largest hurdle that I faced in contacting all the various states, and not just Washington, is that they are restricted, or at least they believe that they're somehow restricted to only putting things on the impaired water list where they have a measurement that's in each segment of their coastal waters, just in-state waters, that shows that the water quality standard is not being met. And obviously, we don't have monitoring in every coastal segment up and down every coast to tell us if ocean acidification is happening or not. So that's what they've kind of used as their reason not to list, is that we don't have enough monitoring yet to know. Okay.
Well, so that brings me to a follow-up question that should have occurred earlier. This is only state waters. So what about ocean acidification in 3 to 200 nautical miles, and what kind of legal evidence do you have for addressing that?
It's legally blurrier, but there are some potential Clean Water Act approaches to some of those federal waters. This has been tried and true, but, it's been used before for atmospheric deposition in state waters and the PRCP list. You'd have to use different provisions to try to get at those federal waters, and the jurisdictional stuff is not as clear. So it's certainly something I'm interested in and looking at, but that might be, chapter 3. But, the Clean Water Act, we do federally have jurisdiction over those waters. And so, but it's not as clear how you get at an atmospheric pollutant in those waters.
There are serious efforts in Congress to strip EPA of its ability to regulate CO2, like the Murkowski Amendment in the Senate in the last term. Would these just obliterate all your efforts if they passed? How seriously do you take them?
Those are very problematic, and I think scientists should be worried about those amendments also. Because, as I mentioned before, the Clean Air Act and Clean Water Act are science-based standards. So there's some measure for, what is the best available science, and how are we creating what the standards are, versus a political trade-off where that might be, covered in an oily politician from an oil state. So it's hard. It could potentially undermine efforts under the Clean Water Act to use it if they basically, pass a law that says, no, you can't do any sort of ocean acidification work under the Clean Water Act, or similarly with the Murkowski Amendment, trying to rid EPA of the power to do it for greenhouse gases. So those are very problematic, and we managed to defeat the Advocacy Amendment before, and hopefully we can hang on to our very important environmental laws that we do have.
In the case of illicit, how would non-point source
That's a tough question. I need you scientists to help me figure that out. I haven't really parsed out exactly what that would look like, but I think it's important. If I could have my dream come true, I think that the next step of what I should be doing is mapping out what these TMBLs would look like, so that there is some sort of guide for, okay, so you get your impaired water listing, what next? It'd be nice to be able to provide some really good examples of that.
I want to thank you for your efforts, which I believe are useful and memorable. The next statement is
But
if the United States were to reduce its carbon dioxide emissions to zero instantly, the oceans would continue to acidify.
yes, they would. And hopefully, it's all degrees, right? We're already having problems with some biodiversity and ocean acidification, and we're bound to see it get worse. So the question is, how much worse?
Well,
Is it going to get?
I think it's useful.
Thank you.
Maybe one more question before we go out to try carrots and fruits.
So I just wanted to follow up on that question of politics. Another thing that I heard some of the new majority party in the House saying is that they would like to try to choke off EPA's ability to be able to do work through funding, through limiting the amount of money that's available to the agencies in different areas. And I don't really know what's being run in terms of set. So if you know something about that, you could say something about it.
I know. But I'm going to go learn about it then and make sure that they have enough appropriations to do what I want them to.
Well, thank you very much.